Why is RAG not enough? The problem lies in connections between different entities in your data. In this, we'll go through context from a basic RAG setup versus a graph RAG setup, where connection through a knowledge graph is essential for solving certain questions from the users. So we'll take a simple business problem, e-commerce domain, where a customer asks, "What's the problem with my order? Why is it delayed? And should I get a refund or replacement?" So we'll use dummy input files and learn that graph RAG provides more context than a basic RAG system. So let's get right into it. So here we have set up the notebook. We'll first of all run the installation for some of the packages, LangChain and Network KX for a knowledge graph. Post that, we are importing some of the libraries. We'll set up our OpenAI API key. So we'll create dummy documents, and corresponding to this e-commerce business use case, we want to show that graph RAG would be able to form connections between various points in the input files. So for that, we have added filler text between relevant pieces of text. We'll see the final PDF in a bit. So we have created 4 PDF documents. These PDF documents are inventory update, order summary, refund policy, and shipment update. We'll go through some of them right now. Yeah. So if I open the inventory update, it says inventory reports describe product availability and warehouse operations. And then this is all filler text. 5 paragraphs of filler text followed by another relevant information. Noise cancel pro headphones are stored at warehouse W22. And then filler text again followed by relevant information. Warehouse W22 is located in Dallas. Similarly, other files exist here where we can see the customer Maya Chen contacted customer support about a recent purchase. Then down below we have another relevant text. Maya Chen placed the order 01007, and down below it says the order contains noise cancel pro headphones, and the original promised delivery date for the order was March 12th. And pertaining to other details of this particular order, they are scattered across documents. So in this particular shipment update PDF, we have daily shipment updates are generated by logistic partners. Order is linked to this shipment ID, and then the shipment is handled by Quick Ship Logistics. And the shipment is currently still in transit, and it was delayed by a regional weather disruption near Dallas. So this is the answer that we need corresponding to a question that asks why this particular order was delayed. So the graph RAG would be able to form these connections, which we'll see in a bit, which the basic RAG setup would not be able to do so because the relevant context is scattered across documents and within a document. So we'll go directly into our setup right now. So we were just here and we created the PDFs. So we'll load the PDFs right now. So we have loaded all the PDFs. We'll create the chunks. We're using basic recursive character text splitter, and we'll embed the chunks right now using an open vector database like Faiz, initiating the LLM. And these are some helper functions to parse the content from the LLM. Now what we'll do is that we'll form the knowledge graph. So a knowledge graph is composed of triplets, where there is basically the subject, the relation with the object as well. We'll see the knowledge graph in a bit. So we are extracting triplet pairs from the chunks, or we can actually pass the entire content of the file in order to extract the triplets to form a connected knowledge graph. We'll see the knowledge graph in a bit. So here I'm passing the full text of the PDF, and then I'm creating the triplets. So an alternative approach is to create the triplets using the chunks that we have created, but that actually loses the connection between the chunks. So instead of doing that, we can utilize the triplets by passing the entirety of the PDF, provided that the PDF are not too large. And then we'll get the final set of triplets here. Now, in order to visualize this particular graph, we can use Network X. So these are the nodes available. And if we just visualize this graph, so this is a knowledge graph that we just created from the dummy PDFs. Now we'll layer in this particular context into RAG so that it has both the vector database context, the normal retriever, along with it, it has the context from the knowledge graph too to empower a better answer generation. So let's say there is a question. We'll have to extract certain entities from the user's question and then search via the knowledge graph in order to identify if there are actually relevant connections to feed into as context for the LLM to learn. So we'll have a function to extract entities from the user query. And yeah, the same function for the answer generation using the basic RAG setup. And now here, this is our graph RAG setup, which contains the retrieved documents from the vector database, that is FIRE's database. The chunks, the relevant chunks based on similarity are retrieved. In addition to that, we are also detecting entities from the user question and then identifying the connections pertaining to the entity that has been extracted from the question. Both these contexts, vector context as well as graph context, make their way into the LLM, which results into a better answer generation, which we'll see right now. Okay, so let's run the comparison. So let's fire a query something like, why is order O1007 delayed, and should the customer get a refund or a replacement? So let's run this right now. So baseline RAG should not be able to get the answer because the context is like spread out. Yeah. So the baseline RAG retrieved these pieces of chunks. So I put the top case 2. So 2 chunks have been retrieved. And the answer is the retrieved context does not provide specific information about why the order is delayed. So it was not able to find the answer because it was spread out within a document and also across documents. Now, if we look at the graph RAG answer, the graph RAG detected these entities from the question. Based upon that, it retrieved from the vector database the same chunks that the baseline RAG retrieved, so that these chunks are the same. But in addition to that, the knowledge graph context provided more connection details based upon the entities asked in the question. And this particular context enabled the GraphRag system to answer the query fully. So for example, order O1007 is delayed due to regional weather disruption near Dallas. The same information that we saw in the PDF, which affected the shipment that is linked to this particular order. Now, it also says that the shipment is currently in transit and has a delay duration of 4 days. But it is still mentioning things such as, according to the refund policy, a 10% refund is applicable if the delivery is delayed by more than 3 days. Since the shipment is delayed by 4 days, Maichan is eligible for a 10% refund. So it was able to answer question on why the order is delayed and whether Maichan should get that particular refund based upon the context that he learned from the knowledge graph through the connections, which were formed using pieces of content across the documents and also within a document which were far apart from each other. So essentially the learning is that the baseline RAG misses things, especially when the context is far apart, which the graph RAG system is able to overcome. So we'll experiment with the graph RAG and other advanced systems in later videos. I'll link the notebook in the description right here so that you can check out graph RAG and then implement more agentic ways of implementing GraphRag 2.